In this video, we are going to be investigating the core ideas around friction at second level. So the outcome we're looking at here is 207A, which says, by investigating how friction, including air resistance, affects motion, I can suggest ways to improve efficiency in moving objects. Now in this video, what we're going to look at is what are the key concepts that we really want to cover with our young people. We're not going to look at the activities to investigate this yet, we're really just going to look at the key ideas and how you can assess that learning before and after. Okay, so the key point really that we want the young people to come away with is that friction is a force, and that might be something that they come to this block of learning without understanding, with no knowledge of. So the way I would suggest assessing their prior learning and the learning that they're bringing into this new topic is by using a concept cartoon. There's a link to this concept cartoon within the links underneath this video. The concept cartoon is very simple. It shows a ramp with a ball running down the ramp and an arrow showing the direction of travel that the ball is going in. So really we're just saying to the young people, this ball has been rolled down the ramp. And the question we're asking them is, why does it stop? Using words or pictures, explain what causes the ball to stop. And it's a really good question and a really excellent way to investigate into the children's understanding of friction. Now, my guess is probably what you'll have a lot of fantastic and wonderful explanations that will revolve around things like the ball's run out of energy. Okay, so it's slowed down and stopped because it's run out of energy. Probably what you won't get is the young people saying that friction as a force has been acting upon the ball and caused it to stop. And that's a bit of learning that we're going to try and look at today. I would suggest a great way to get into this with the young people is actually by using Newton's first law of motion. Now that might sound a bit fancy, but it's really helpful here. And it's also another way of introducing a famous scientist to the children. So Newton's law of motion says that everything will stay at rest and everything in motion will stay in motion unless acted upon by another force. Now, I would suggest tackling this in two ways with your children. Now, I've got a roll of sellotape here, but you could just as easily use a ball. So if we take this statement in two parts, using this roll of sellotape, we can investigate it with the children. So the first part of the statement says, everything at rest will stay at rest. Now, if you have your ball or your roll of sellotape in front of the children, and you say, boys and girls, the first part of this law, of Newton's first law of motion, is that everything at rest will stay at rest unless acted upon by another force. Now that makes sense, and it'll make sense to the children. This roll of sellotape is not all of a sudden going to start rolling around on my desk by itself. It needs to be acted upon by a force. So that's probably going to be my hand bashing it and making it roll. However, the second part of the statement is the bit that might cause the children trouble or might be new learning for them. And it says, everything in motion will stay in motion unless acted on by an external force. And that's the bit. Everything in motion should stay in motion unless it's acted on by another force. So that's telling us that when the roll of sellotape or the ball stops rolling, it doesn't stop because it's run out of energy. It stops because it's been acted on by another force, and that force is the force of friction. So that's a visual way that we can help the children understand that. The sellotape or the ball isn't coming to a stop because it's run out of energy, but it's coming to a stop because it's been acted on by another force, and the name of that force is friction. So what we need to do now is help the children understand what friction is. Now for the rest of this video, we'll explain a little bit about the science, and in the following videos, we'll have some examples of experiments and investigations that you can do with the children to give them that inquiry-based, deep understanding of friction. So what is friction then? Well, friction is a force that opposes motion or makes it difficult for two objects to move across one another. And the amount of friction depends on a few things. The size of the surfaces in contact, the type of surfaces in contact, and the pressure pushing those two surfaces together. But how does friction work? Well, simply, friction is caused by the interference of the atoms or the molecules of each object sliding over each other. Now, Children might think that things look very smooth. So, for example, this piece of paper on the desk might look very smooth, and they think, well, Mr. Brown, how could there be interference between these two surfaces? The table seems really smooth and the paper seems really smooth. And it's about showing them and explaining to them that actually, if you were to zoom in with a powerful microscope and see things at a molecular or an atomic level, it wouldn't be smooth, it would be rough. And it's that roughness, those two surfaces rubbing across each other, that causes friction. And it's helpful to show them images such as this one. Okay, so using Newton's first law of motion and a simple demonstration with a ball or a roll of sellotape, then we've introduced the children to the idea, the key bit of learning, that friction is a force. We've identified our starting point for this block of learning by using our concept cartoon. We're able to look at that and see what is the explanations the children are giving us as to why the sellotape is moving. If we've got some children already telling us that it's being acted on by a force, we can have a conversation with those children and investigate further their understanding. If no one's mentioning that, then we know where to go with our learning. At the end of our block of learning, when we're finished doing our friction investigation and lessons, we can ask the children to complete this again, just the same one, and that will be our post-assessment. And we're hopefully in our post-assessment, when we ask them to correct or make any additions to their first go at this concept cartoon, we should get a clear explanation from the child that the reason the ball is coming to a stop is because the force of friction has been acting upon it. Maybe even giving us a diagram of how two surfaces, even though they may look smooth, when we zoom on them with a microscope, we can see that they're rough. And that roughness is the force of friction causing the object to come to stop. So there we go. That's how we can introduce the concept of friction using Newton's first law, how we can use a concept cartoon as a pre and post assessment, and how we can use that first law as a way to introduce the idea of friction as a force.